Hey, what's up? Mr. Cox here, coming with you with another Educanon video. I thought in the name of spring and talking about ocean currents, this might be a pretty good video to start us off. Let's take a look. Alright, so now that fun's over with, we're going to talk a little bit about ocean currents and why do they move. Okay? So we've got two different types of ocean currents. We've got deep ocean currents and then we've got surface ocean currents. So ocean currents that exist on the surface of the ocean and then ocean currents that are deep all the way down to the bottom of the ocean. The entire body of water, if we talk about ocean as one body of water, it all circulates. It all mixes together, okay? And it's because of these currents that happens. If we dive into a little deeper, dive into the deep currents a little deeper, right? They're caused by differences in the water density. Cold water is more dense. The particles are compacted closer together, so that's going to sink. Warm water is less dense, and that's going to float, right? So temperature is one thing that affects the water density, right? So temperature, cold water is denser than warm water. Salinity, which is really talking about how much salt is in the water, okay? The higher the salt concentration, the denser the water is going to be. So in places where there is a lot of salt, say for example evaporation, right? Where evaporation occurs, there's a lot of water going into the atmosphere. What's left over? The salt, right? So that's going to be a high concentration of salt where there's lots of evaporation. And so that's going to be denser water where it's going to sink. Okay? There are three factors that affect these two things, temperature and salinity. Right? First one is latitude, fatitude, where we are on the planet in relationship to the equator. Right? How north or far south we are from the equator. Okay? The closer you are, the more direct sun you get, the hotter the temperatures are going to be, which means the less dense the water is going to be. Wherever we get rain, right? More rain, that lowers the amount of salt concentration in that area, and so the density goes down, okay? Which means it starts to float, right? More dense, sinks, less dense, floats, okay? And then evaporation. As H2O evaporates, salt concentration grows or gets higher, and the density goes up, right? Of the water that's left there, the salt that's in it, the concentration of salt goes up, which means our density goes up, and so that water is going to sink. So deep ocean currents, right? Temperature and salinity both affect the density of the water, and that's really what drives these deep currents is the density of the water. Cold water sinks. Salty water sinks. Okay? If we dive a little deeper into latitude, right? Where we are on the Earth, where we are on Earth relative to the equator and the poles. Water is colder and saltier at the poles. Right? So the water at the poles, it's pretty easy to understand that it's colder there, so it's going to sink, but it's also saltier there, so it's going to sink as well. Both of those are causing the density to increase, and so the water is going to sink. Warmer, if we look at the equator, the water is warmer, but it's also saltier. Why? Because of evaporation, right? Evaporation is taking the water away, salt's left over, but the water's too warm to sink, right? So you've got kind of conflicting forces acting on that water. The heat's causing it to float, the salt's kind of causing it to get lower, but the water's too hot to sink, right? So it doesn't sink. Water rises at the equator. And then precipitation. Rain, snow, hail, sleet are all forms of precipitation, but they are all fresh water. Fresh water meaning there is no salt whatsoever. they all add fresh water to the ocean. So wherever we have a lot of precipitation, right, that reduces the salinity in places where we get a lot of rain or snow or sleet or whatever. And then where maybe we have a drought or where we get very little precipitation, right, the salinity increases, which means my density increases, and so that water is going to sink. So 3 factors affect the salinity and temperature: latitude, precipitation, and evaporation. Evaporation, right? Very simple. Evaporation removes fresh water and increases the salinity. More evaporation at the equator than at the poles. Why? Because there's more direct sunlight at the equator, right? There's more direct sunlight at the equator, which means the water is going to evaporate out of there faster than it will at the poles. Okay, so we have saltier water there. All right. Surface currents. So we've got deep currents, and then we have surface currents. Surface currents have 3 factors that affect them as well. First thing is what's called global winds, right? So we have wind blowing across the ocean. As that wind blows across the ocean, it pulls water with it. If the wind blows in one direction for a long period of time, it's going to drag that water into a pattern, and we call that a current. Right? So wind is caused by the unequal heating of the earth, right? Around the equator, more direct sunlight, so the air gets heated hotter. That air rises, cool air replaces it and gets warmed and replaces it. So you've got this circulation of air that causes surface currents to be created. The Coriolis effect, right? The fact that our earth is rotating on an axis and the water kind of lags behind, that gives us currents as well, right? So the rotation of Earth causing fluids to curve. And then the barriers, right? Continents act as barriers. So they are going to stop a current or change the direction of a current because you can't go through the continent, right? So this current comes and hits the continent, and it either has to diverge and go both ways, or it goes one way or the other, okay? And so these 3 things affect my surface currents. Ocean currents affect on climate. Climate is the precipitation and temperature over a long period of time, right? When we define climate, we look at the average rainfall and temperature of a region over a long period of time. That's what determines the climate. Weather is the day-to-day change, okay? Ocean currents affect climate in areas close to the coast, right? So there's a reason that people want to move out to California. It's beautiful weather out there. Why? Because it gets a lot of warm air coming off the Pacific Ocean, right? Because there's a current that brings that air to the California coast, and then the California coast reaps that benefit because with that warm current comes warm air, right? So if a wind blows across a cold ocean water, what might the coast next to the ocean feel? I want you to answer that. Think of what we just talked about, right? If the wind blows across a cold ocean, what might the coast of that ocean feel like? So type of current. Warm currents, if we've got warm currents, they bring warm temperature. So with a warm current, it's dragging warm air, right? With warm air comes moisture. So typically, with a warm current, you get warm air and moist air, right? So you get more moisture and warm air. The example is the Gulf Stream, okay? So right here, we'll look at this in class more, but right here is the Gulf Stream. This is a warm current that is that's being brought from the equator. It's coming into the Gulf, warming the Gulf, coming out of the Gulf, and then traveling across the Atlantic Ocean into Great Britain, into London, and so on, into the Norwegian Channel as well. And so what happens is this brings a whole lot of warm, moist air with it. And then London, or the Great Britain, reaps the benefit from the Gulf Stream because the Gulf Stream delivers warm air and moist air to it. All right? Cold currents obviously bring cooler temperatures. Cold currents also bring less moisture, right? So if a current is cold, it's going to be drawing cold air with it, and typically that cold air is dry air. wind and ocean currents work together by means of conduction and convection. Right? The air and the wind, or the air and the water, they're touching each other. That's conduction. Right? So we have heat leaves the water, goes to the air, or heat leaves the air and goes to the water. Right? You got both ways because they're touching each other. That's conduction. Right? When you touch a hot pan that's on the stove, the reason that it's hot is because of conduction. The pan is touching, or the handle's touching the pan, which is touching the stove, and all of that heat transfers to the handle. That's conduction. And then convection, we talked about that. Warm air rises, cool air sinks. Warm water rises, cold air sinks. And so we have this churning caused by conduction and convection. Okay? So going back to this image here, right? If this represents the North Pole, and this represents the South Pole, and this represents the equator, you've got warm water being warmed by the sun, right? Rising, and then it, this should be backwards, okay? But you've got warm water rising and moving towards the poles. As it gets towards the poles, it cools off, sinks, and comes back, right? That's convection. Those are convection currents. Okay? We'll look at this example in class. But lastly, what I want to talk about is this ocean conveyor belt. All of our oceans are connected. Okay? They are connected, and we call it this ocean conveyor belt. The ocean conveyor belt starts at Greenland. It starts up by Greenland, where we have very cold water becoming more dense and sinking. And as it sinks, it has to draw more water to replace it. And it draws that water from the warm water coming from the equator. Right? So a lot of water is moving around Earth. All of the water moves around Earth. And it starts from the thermohaline circulation. Right? Thermo means heat. And so the circulation is starting at the North Pole, or by Greenland, which is right here. Okay? This is important because it warms the waters to the north, right? North and south. It warms those waters, and it also cools off the waters at the equator. Okay? So it kind of balances the Earth's out. Also, this conveyor, the oceans are a huge reservoir of CO2. And so because we have water moving, it's able to pull CO2 out of the atmosphere and then bury it deep within the ocean and let organic aquatic ecosystems use that CO2 rather than keeping it in the atmosphere. Right? So this is important for a lot of different reasons, but those are two. And then lastly, unequal heating of the Earth, right? Water is a lot more difficult to heat, so it takes a lot of energy to warm water. Okay? Air, on the other hand, is very quick. It warms up fairly quickly. That's why, in the beginning of a day, right, the air temperature might be 30 or 40 or 50 degrees, and then by the end of the day, it might be 60, 70, 80 degrees. Right? There's a big fluctuation because it doesn't take a lot of energy to heat the air. Water, however, takes a lot of energy. Right? Water temperature doesn't fluctuate day to day very, very much. Right? If it's 40 degrees at 8 a.m., it might be 41 or 42 by the end of the day, but it's not going to change that drastically because it takes a lot of energy over a long period of time to change the temperature of the water because it takes a lot of energy. Land, on the other hand, takes a small amount of energy to raise its temperature. Right? So if I have sun beating down on land and water right next to each other, which one's going to raise its temperature the fastest? Is it going to be the land or is it going to be the water? We'll talk about it in class. All right, that does it for our notes. I hope you liked them. This is all about ocean currents. Next one's going to be about climate. Those two go together. All right. This is going to be a shout out to all of my hours. First, second, fourth, sixth, all of you. Peace out, homies.